Good day and welcome to my physics class. I am still on current electricity. In my previous videos on current electricity, I have treated the definitions of the terms in the first part. The second part of the video, I treated how we can calculate combined or equivalent or total resistance in both parallel and series arrangement of resistors. And as well, I did some calculations on how we can calculate equivalent resistance for the combination of both parallel and series arrangement in a circuit. So today we want to have a look at the application of Ohm's law. From Ohm's law, we have this formula generated, which is a common formula. V is equal to current times resistance. That is derived from Ohm's law. So this is very important. V is equal to IR. Is very, very important. Okay? Now, how do we now apply this in solving problems? This is one of the questions that we are going to treat today. The question says 3 resistors with resistances 250 ohms, 500 ohms, and 1 kilo ohms, K represent kilo, are connected in series. A 6-volt battery is connected to either end of the combination. Calculate the potential difference across each resistor. Okay, it is very obvious that this one is on series arrangement. So the first thing I will advise you do when you are writing WAEC or NECO or any other O-level exams, you are supposed to draw or sketch rather the circuit diagram. That one will help you extra mark. Let's go and have a look at the circuit diagram for this question. This is the circuit diagram for the question on the board. In my previous video, I've explained all this arrangement. The horizontal arrangement of resistors like this represent series arrangement. And since we have 6-volt battery connected to all of them, so this is the 6-volt battery here. So this is the direction of current. This long pole is the positive terminal. The smaller one is the negative terminal. So current is coming out from here. Then the same current that enters 250 volts will enter 500 volts, will enter 250 ohms rather, 500 ohms, and 1 kilo ohms. Now, don't forget this 1 kilo ohms is the same thing as 1000 ohms. Why? Because kilo stands for 1000. So 1000 times 1, that will be 1000 ohms. That means I will be making use of 1000 ohms in the subsequent steps I'm going to take. Now, having drawn this, what is the next thing? You should realize again that when resistors are in series, they cannot use the same voltage, but only the same current. That means this voltage can only be used by the combination of all these three. Not that one of them can use this. No. The combination of these three together will hold this. Therefore, the first step is to find the equivalent resistance, which is the combined resistance for the 3 resistors. And when you are dealing with a series arrangement, that means the total resistance will be 250 plus 500 plus 1000. That will give us a total of 1750 ohms. Now, it is this 1750 ohms that will be using this battery of 6 volts. So that means from Ohm's law, V equals to current times total resistance now. So our V, don't forget, is 6 equals to current, which we are looking for in the whole circuit, because without knowing the current, we cannot find this question. So times 1750. What will now be I? I is 6 divided by 1750. And that is reduced to 3/875 amps. So this is the current flowing through the three resistors. So once we have known the current flowing through each resistor, it will be very easy for us now to find the potential difference for each of the resistors. That means potential difference V1, which is for resistor R1, that will be current times R1. And that will now be equals to, current is 3/875 times R1 is 250. So that will give us 6/7 volts. For V2, that will be current times R2. And current is the same. Don't forget, the same current passes through each resistor in what? In series. That will be 500 times, current is 3/875. 3/875 times 500. And that will give us what? 12/7, which is 5/7 volts. So for the third resistor, which is 1000 ohms, that will be 3/875 times 1000. That will give us 24/7, which is 3 ohm number, that's 21. 3/7 volts. So that is the answer. By the time you add these three together, when you do that, you must get this 6 volts back. If you don't get 6 volts back, that means something is wrong somewhere. Okay? Yeah. The next example is about 3 resistors connected in parallel, as you can see in the question. A 2.4 volt battery is applied across a parallel combination of 3 resistors with resistances 2 ohms, 4 ohms, and 12 ohms. Calculate the current in each resistor. Like I told you, in WAEC or NECO or IGCSE or any other O-level exams, it's advisable you sketch the diagram for the circuit. We call it circuit diagram. So this is what I'm going to do. I'm sketching the circuit diagram. Okay. Now, this 2.4 volts is this. 2.4 volts. Let me make the battery. Okay, 2.4 volts. Let me call this one R1, which is 2 ohms. Call this one R2, 4 ohms. This for R3, 12 ohms. So we want to find the current in each resistor. It's a very simple question. Remember, or if you have not watched my part 2 video on current electricity, go and do that. When you have parallel arrangement, each resistor will use this voltage. That means 2.4 volts will be used for this, 2.4 volts will be used for this, 2.4 volts will be used for this. That is the condition for parallel arrangement. That means I want to find I1 now. For R1, V1 will be equals to I1 times R1. I'm using I1 as the current that will flow through the resistor 1. What is V1? 2.4 equals to I1 times R1 is what? 2. So by the time you do that, what is your I1? I1 will be 2.4/2, which is 1.2 amps. Okay? Do the same thing for others. V2 is equal to I2 times R2. And V2 is also 2.4. Remember, the voltage remains the same. I2 times R2 is 4. Then you divide both sides by 4. I2 will be 2.4 over 4, which is 0.6 amps. Okay, let's do the third one. Third one, which is V3, that will be I3 times R3. Don't forget V3 is also 2.4. Then I3 times, and R3 is what? Is 12. So dividing both sides by 12, I3 will be 2.4 over 12. So I3 is equal to what? 0.2 amps. So by the time you add all this current together, it will give you the total current. Total current will be I1 plus I2 plus I3. And that is 1.2 plus 0.6 plus 0.2. And what would that be? 1.2, that's 1.8, that's 2 amps. That means the total current in the circuit is 2 amps, while the current in each resistor is 1.2, 0.6, 0.2. This is the last question on this video, current electricity, which is the last part of this topic. Now, we want to calculate the current I in the circuit. That means, look at this circuit. You cannot say this is series, you can't say this is a parallel, but rather is the combination of both parallel and series. So what do? We need to find the current. I means the current in the whole circuit, because it's coming from the battery. So it is the one in the whole circuit. That means to find the current in the whole circuit, we should find the total resistance in the whole circuit. That means I want to add all these 1, 2, 3, 4, 5, these 5 resistances together to become one. How do I go about it? In my previous video, I've explained that. So now, when the current is coming this way, this is a T-junction. Any T-junction shows parallel arrangement. Don't forget that. That means R1, current that enters R1 will enter R4. That means R1 and R4 are in series. Okay? Then the current that goes here also will enter R2 and R3. That means R2 and R3 also are in what? Series. I hope you are following me. Fine. So that means let's combine them together. Series. Combined, series, combined. Alright. R1 and R4, these and these. I've added them together in series. 2 plus 2, 4. R2 and R3 in series. Added together, 4. So definitely, since the whole of this one and this one are in parallel, that means I'm going to add these two together now using parallel formula. So that means parallel formula will be 1 over R 1, 2, 3, 4. I'm using 1, 2, 3, 4 to explain that I'm finding the resistance that combines R1, R2, R3, R4 together, which is using this and this. That will be 1 over 4 plus 1 over 4, which is 1 over 2. So by the time you turn this one upside down, R1, 2, 3, 4 will be equal to what? 2 ohms. Okay? Now, having done that, that means when the current that enters here comes out of this another T-junction here, the one that enters here also will come out of they will meet, both of them will meet at the junction, then they will come out and enter here and go back to the what? To the battery. That means the total current that leaves the battery is entering 1 ohm here. Therefore, 1 ohm and the whole of these are in series. That means total resistance now will be these two, which is for the whole of these 4 here, plus this one, which is separate. That will be 3 ohms. So having done that, you can now find the current. I will be V over total resistance. And what is our V? Our V is what? 12. Over total resistance is what? 3. So answer is 4 amps. That is total current in the whole circuit.